Hello and welcome to my YouTube channel Electrical Hub. Here we will discuss about the energy management. Energy management is a very important aspect of electrical energy. It will not only save the power and the cost of production of the power, but it will also help to preserve the nature and reduce the carbon emission. We are here to start with our first topic, transmission and distribution losses. This topic we will discuss about the losses of the transmission and the distribution. We will also come to know how one unit of energy being saved at the user end is equal to the 2 units of energy being produced at the producer end. So let us start with the transmission and distribution losses. Before transmission and distribution of power, which is generated at the generating station, there are also a number of losses occurred that during generation of power. But here, as we are going to calculate about the transmission and primary distribution losses, so here we are considering the efficiency as 1 unit. Means we are taking the generation as a unit. While transmitting the power, it should be transmitted at a high voltage because higher the voltage, lower will be the current, and the power loss in the line is directly proportional to the square of the current and resistance. Since resistance cannot be changed, so power loss will be directly proportional to the square of the current. So the lower the current, lower will be the loss of power. Depending upon the voltage, there are 4 types of transmission. First is extra high voltage transmission, when the voltage is in between 400 kV to 800 kV to transmit the power at a longer distance. It is known as the extra high voltage transmission. And when the voltage is in between 200 kV to 400 kV, it is known as high voltage transmission. Sub-transmission is done at 132 kV, 110, 66 or 33 kV. Now comes the fourth one, that is DC transmission. DC high voltage up to 800 kV is also used to transmit the power when the distance is more than 1000 km. During transmission of power, it is important to minimize the loss and transmit the power economically. But there are few losses which cannot be eliminated. So, according to the cascading efficiency system, we will come to know about those losses accordingly. First, we will discuss about the step up substation. Step up substation. When the generated power voltage is stepped up by a generating transformer to a voltage of 400 kV or 800 kV, some losses occur due to the transformation of power. That loss is 0.5% maximum. So the efficiency of the substation is 99.5%. Thus, let us consider N2 is equal to 99.5% after the voltage being increased by the transformer to a 400 kV or 800 kV. It is transmitted to a longer distance over 100 or 1000 kilometers. During this process, it incurs a loss of 1%. So, the efficiency of the extra high voltage transmission is 99%. Thus, N3 is equal to 99%. High voltage transmission. After power being transported to the high voltage substation, it is stepped down to a voltage of 200 kV or 400 kV as per the requirement, and then it is again transmitted to the subtransmission unit. In this process of stepping down the voltage and transmitting the voltage to the subtransmission unit, it incurred a maximum loss of 2.5%. So, the efficiency of high voltage transmission is 97.5%. After the power being received at the subtransmission unit at a voltage of 200 kV or 400 kV, it is stepped down to a voltage of 132 or 66 kV, from where some of the power is transmitted directly to the industry at a voltage of 132 or 66 kV, and the rest is transmitted to the distribution substation. This process incurred a loss of 4%, so the efficiency of the subtransmission is 96%. So now when the power from the subtransmission unit is received at the distribution substation at 132 or 66 kV, it will be stepped down to a voltage of 11 kV, 22 kV, or 33 kV, depending upon the requirement to the different industry or to the different distribution location. In this process, due to the transformer, it will incur a loss of 0.5%. So, the losses of distribution substation is 0.5%. Thus, the efficiency is 99.5%. Finally, comes the primary distribution. Primary distribution is done at 11 kV or 33 kV to a different industry or for secondary distribution. It incurred a loss of 5% because here the current is high. So the efficiency of primary distribution is 95%. Thus, N7 is equal to 95%. Thus, according to the cascaded efficiency from generation to the primary distribution is 87%. It varies from 87 to 83% depending upon the condition of the line, transformer, etc. So, as per IEC standard, efficiency of transmission and primary distribution is 87 to 83%. So let's discuss how one unit saved at the user end is equivalent to the 2 units of generation. First, according to the cascading efficiency, we know that the efficiency of transmission and primary distribution is 83%. When the power reaches at any industry, then there is a transformer. Efficiency of the transformer is approximately 95%, while the efficiency of the motor is 90%. But the energy lost in the coupling, pump, flow control bulb, throttling bulbs, fan, etc. is 30%. Thus, its efficiency is 70%. Thus, overall efficiency of energy being used at the industry is equal to 50%. Thus, 1 unit saved at the user end will save the cost of production of 2 units. Thank you. Please like, share, and subscribe to my channel so that this information reaches to the maximum of the people and also motivate me to make more videos like this. Thank you.